Hello everyone, my name is Derive, and today I will be presenting to you global precipitation extremes under a quadrupling of atmospheric carbon dioxide. Since I like to do climate science, my research question today would be, does global warming lead to more extreme rainfall? My data of choice is idealized climate model experiments, and the two experiments I use is the pre-industrial control experiment or piControl and the quadrupling of carbon dioxide experiment or abrupt 4 times CO2. piControl is pretty much a world without humans where the Industrial Revolution never happened. It is generally used to be the baseline control for any comparisons. On the other hand, 4 times CO2 is the same as piControl, just with quadruple the carbon dioxide from 280 to 1120 parts per million. The model of my choice is the Community Earth System Model 2 or CESM2 by NCAR, and I downloaded 500 years of daily precipitation data. Rainfall values is presented in units of millimeters per day. Generally, values less than 40 millimeters is considered light to moderate rain. From 40 to 240 is heavy rain, and anything above 240 is exceptionally heavy rain that you can only find in hurricanes, monsoons, and thunderstorms. For example, this map shows the rainiest day of the year in year 500 of the simulation. You can see that the values go from 0 to 300 millimeters, and you can see features in the atmosphere such as the intertropical convergence zone, storm tracks, and even a hurricane that's hitting Texas right now. On the other hand, the abrupt 4 times CO2 experiment shows a much higher rainiest day of the year where values can go up to 900 millimeters per day. To study this further, here are my methods. First, I extract the rainiest day of the year in each grid point for all 500 years for both experiments. Second, I fit a generalized extreme value distribution to the data and then extract the parameters. 3, I calculate the 100-year return level of the data. And 4, I make a lot of maps and plots. That's a description of what I did. In truth, I fit the CDF of the GEV distribution to the data. I then solve for the maximum likelihood estimator using these 3 derivatives. And then I put the parameters mu, sigma, and chi into the return level equation here. Here's the result of my analysis. This plot shows the time series of the rainiest day of the year at Stanford, California. The blue is the control experiment and the red is 4 times the CO2. You can see that by quadrupling the carbon dioxide in the atmosphere, the rainiest day of the year increased from 40 millimeters per day to around 70 millimeters per day. Although this is a small increase, it still shows that there is a response by the climate system from just increasing the carbon dioxide. As shown here in the return level plot for the maximum daily precipitation at Stanford, you can see that the probability of an extreme event increased with 4 times the carbon dioxide. So for example, if you draw a line at 100 millimeters of daily precipitation, in the control experiment, it's an event that happens once every 200 years. But with 4 times the CO2, it's an event that happens roughly once every 15 years. So an event that used to happen once every 200 years now happens once every 15 years. After repeating the process for everywhere on Earth, we can now generate the 100-year return level plot for precipitation in both experiments. This one here shows the one for piControl, where you can see that the values are pretty moderate. On the other hand, this is the 100-year return level of abrupt 4 times CO2. You can see that large swaths of the Earth now experiences up to 900 millimeters per day of precipitation, which is a staggering amount of rain. 240 millimeters is already considered exceptionally heavy rain. I cannot imagine what it's like for 900. This map shows the difference between the last 2 maps. You can see that most of the world experienced an increase in amount of precipitation for the 100-year return level events. That means for most of the world, the rainiest year of the century will become much more extreme, where you can see many parts of the tropic experience an increase of more than 500 millimeters per day. Altogether, quadrupling the amount of carbon dioxide in the atmosphere is probably a very bad idea. As I have shown, it will significantly increase the magnitude of extreme rainfall in many parts of the world, at least according to the model. And thank you for listening.